Hello and welcome to the Comedy Recycling Theory. This segment is going to be why science misunderstands both the Cepheid variables and the type 1a supernova that are observed out there in the universe in general. Part of this has been covered in another segment, but this is another aspect of that same idea. The idea is both the Cepheid variables and the type 1a supernova are supposed to be a standard reference foot candle, which science assumes, and I use that word assumes, is the same brightness wherever you go. And every time we see one, that they're the same, that the intrinsic brightness of it will be the same from whatever direction and wherever we see it from. The idea that you get in trouble with that from is the comedy recycling theory claims that because our universe is a closed universe and that it has a preferred reference frame superimposed over it, that the universe actually runs faster at the center and it runs much, much, much slower at the outer edges, including all the way to a stop at the outermost edge of our universe, if our universe is completely closed off and is the inside of a giant black hole. It's the inside neutrals or inside active zone of a universe-sized black hole, at least according to the comedy recycling theory. Now, what that means is that when you see a Cepheid variable or a type 1a supernova that's at a very far distance away, especially like if it's halfway across the universe or one of these that has a very high redshift to it, science has been assuming that that redshift is caused by the expansion of the universe, and then is assuming that the brightness of that type 1a supernova or Cepheid variable is exactly the same as one that's very close to us, that we can observe much, much closer to us. Whereas the comedy recycling theory says that's not really the case at all. What instead is the case is that the brightness of this object will be considerably dimmer, because the further you go out towards the outer edges of the universe, the dimmer these objects actually are. They're actually running slower than we are, and that we are actually observing the universe at a real-time rate. We are not observing it Doppler shifted or slowed down. That's the one assumption that mainstream science has gotten into a big amount of trouble, and that's one of the reasons they keep expecting the need for dark energy. That's one of the reasons they keep expecting our universe to be expanding at not only a small rate, but at an expanding rate, without having any reasonable source of energy to keep providing the energy, to keep accelerating all the matter that we see. And that also makes our universe look like it's almost exactly filled with enough matter to close the universe off, even after it's theoretically been expanding for 13.7 billion years from an area much, much, much smaller than the head of a pin. And which really doesn't make a lot of sense when you think about it, to realize, where did all the energy come from? Where did all this mass come from? Where is the energy coming from to not only expand the universe, but to keep it accelerating, and to accelerate all the mass we see, and then to make the universe appear to be almost having enough mass to close off the universe? That just doesn't make sense from a logical point of view. Whereas the comedy recycling theory says that it's much more likely that if our universe is closed, it's got a fixed amount of energy, it always has had this amount of energy, it always will have this amount of energy, but that everything we see further out that we're actually seeing redshifted is at a real-time rate that we see to us. It's a what you see is what you get universe, that what you see out there is exactly what we get. And then mainstream science gets into trouble because they take the visual data that they observe and then they correct it to agree with what the theory of relativity tells them. Oh, there is just like here. Well, that's all right if there is just like here, but in this case, in the comedy recycling theory universe hypothesis, that that's not the case at all, that there is not at all light here, and that that's exactly what we see when we look at the real data. So when you go out and correct the real data that we actually see for what you think we should see because you believe the theory of relativity, because it tells you that everything else is just like here, when what you see is that everything that you see further and further away is less and less like here, that it's more and more slowed down the further away you go. That's where science gets into a lot of trouble, and that's one of the reasons that science misconcludes that the universe is expanding and expanding at an expanding rate. That our 1A type supernova and our Cepheid variables, which are assumed to be standard candles and just as bright everywhere when you see one, that's not really the case by the comedy recycling theory hypothesis. That what we actually see is what we actually get, and that when you see something a good deal dimmer, a good deal more redshifted further away from us towards the outer edges of the universe, that's because the object there is actually more slowed down. It's actually aging at a slower rate. It is actually encountering real time at a slower rate than we do, and that's also one of the reasons that I think science both overestimates the distance as far as how far away things are, and that they overestimate the energy production of many of these things at a distance, because they assume that they're actually occurring at the same rate that we do here on planet Earth. So there may be a double overcorrection factor on the conventional theory hypothesis for both the size of the universe, not so much the age of the universe, but for the energy output of items within the universe. So that's today's segment for the comedy recycling theory on both our standard foot candle, the Cepheid variables, and the type 1A supernova. You can read more about it at www.cr-theory.org.